Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. Today we're going to talk about the problem of the day 21. For the problem of the day 20, it was a problem. You can just prove that two angles are equal very easily. So I'm gonna jump that problem. So let's look at this problem. For triangle, if three inscribed squares are equal, then it's an equilateral triangle. I really love this kind of problem because it like give you a research topic, right? Just an assumption there. For triangle, if the three inscribed squares are equal, that's an assumption. And the guess would be, then it's an equilateral triangle. So let's look at this problem. First, we draw the triangle here. And we have to understand what is the inscribed square. Right? How to draw an inscribed square? You can just imagine that I can draw a parallel line, right? I can draw infinite number of parallel lines here and here. So for each parallel line, I will check the length of this parallel line and the distance from this parallel line to the BC side, right? Once the length of the parallel line equals to the distance to the BC side, then we call it an inscribed square. That's actually already tell us how to solve this problem. So let's just find the altitude here. Since it's altitude, let's call it AD, and EFGH, that represents for our inscribed square. And let's assume that AE to AB, right? This ratio equals to lambda, and we know that lambda is less than 1, larger than 0, right? And we can assume that BC, the length of BC is A, and the length of AD is H, right? So we can use lambda, A, and H, calculate for the length of the edge of the inscribed square, right? EF equals to, see, EF to BC, that equals to AE to AB, which means EF equals to BC times AE to AB, which is a lambda, right? That's for EF. And for EG to AB equals to BE to AB, which is 1 minus lambda. So EG equals to AD times BE to AB, which equals to H times 1 minus lambda, right? And we know that it's an inscribed square, so EF equals to EG, which means A lambda equals to H 1 minus lambda, which means lambda A plus H equals to H, right? So we got lambda equals to H divided by A plus H. And the length of the inscribed square, EF equals to A lambda, which is AH to A plus H. Now we understand if we just pick a side, and we just pick this side, right? And we want to know the length of the inscribed square, we find it. It's AH to A plus H, which is twice of the area of triangle ABC to A plus H. that is length of the side and length of the altitude on this side. So that means we just find the length of the inscribed square on the side BC, and what about on the side AB, right? So for AB, let's just rewrite this one. So let's call it twice the area of triangle ABC 2a plus HA. Okay, that's the altitude from vertex A. And for the AB length, that's for the BC length, right? For the BC edge, that's for the, and for AB edge, we have lambda. So this is, let's call it lambda A, and then we have lambda C, which equals to twice of the area of triangle ABC divided by C plus HC, right? Or we can write it as C times HC to C plus HC, right? And we already know that, wait, this is not the lambda, this is length, right? Length of the length of the inscribed squares on the AB side. Okay, so we know that all these three inscribed squares are equal, which means any two of them are equal. Then let's just make CHC to C plus HC equals to AHA to A plus HA, right? And we already know that CHC equals to AHA, right? Because that's twice of the area of the triangle ABC. So that means we are looking for the CHC and AHA, that's the production are equal and also the summation are equal, right? And based on this, we can easily get that C minus HC equals to A minus HA, right? We can square this and minus 4 times of this, then we square of that, and then we get this one. Okay, we have this one here, then we easily get that C equals to A and HC equals to HA. And then similar for the other side, so we finally get A equals to B equals to C, and HA equals to HB equals to HC, which means this is an equilateral triangle. Okay, so this problem I think is a problem probably for 8th or 9th grade, right? It's basically like a little research topic that asking yourself to derive all the conditions from a description, right? The description is like 3 inscribed squares are equal, and you need to figure out how to model it, how to use a math language to represent for this description. Okay, that's it. I hope you like this video. See you in next one. Thank you.